Hey, what's up everybody? This is Sean, Woleslagle Cybersecurity, and today we're going to continue our Python journey. So, last time we left off right before loops under the introduction to if statements, and today we're going to go ahead and continue that journey with loops. So, in programming, loops allow programs to iterate and perform actions a number of times. There are two types of loops, for and while loops. While loops. Let's begin by looking at how we structure a while loop. We can have the loop run indefinitely or similar to an if statement. Determine how many times the loop should run based on a condition. I is 1 while I is less than or equal to 10. Print I. I is 1 plus I plus 1. This while loop will run 10 times, outputting the value of the I variable each time it iterates. Let's break this down. The I variable is set to 1, right? The while statement specifies where the start of the loop should begin. Every time it loops, it will start at the top, outputting the value of I. Yep. Then it goes to the next line in the loop, which increases the value of I by 1. And again, this goes back to what I said in my last video, which is that plus equals makes this a little easier to understand. Then it goes to the next line in the loop. Oh, I already said that, sorry. Then, as there is no more code for the program to execute, it goes to the top of the loop, starting the process over again. The program will keep on looping until the value of the I variable is greater than 10. For loops. A for loop is used to iterate over a sequence such as a list. Lists are used to store multiple items in a single variable and are created using square brackets. Let's learn through the following example. Websites is Facebook, Google, and Amazon. And for site and websites, print site. So it's just going to go through each one of these for each site, and each one of these websites print that. So Facebook, Google, Amazon. This for loop shown in the code block above will run 3 times, outputting each website in the list. Let's break this down. The list variable called websites is storing 3 elements. The loop iterates through each element, printing out the element. The program stops looping when it's been through each element in the loop. To give a real-world scenario, you could create a program that checks if a website is online or if an item is in stock. You would loop through the website list, add functionality inside the loop to check the website, and output the results. The Python for Pen Testers room shows you how to use Python to enumerate a target, build a keylogger, scan a network, and more. We're definitely going to do that. In Python, we can also iterate through a range of numbers using the range function. Below is some example Python code that will print the numbers from 0 to 4. In programming, 0 is often the starting number, so counting to 5 is 0 to 4 but has 5 numbers. 0, 1, 2, 3, and 4. For I in range of 5, print I. On the code editor, this is important. Because the range is 5, you don't expect to see 5 because when we start, we always start with 0. On the code editor, click back on the script .py tab and code a loop. Alright, we can get rid of that. For I in range of 50. Well, we want to do 51, right? Because we have to add that extra one. And then we print I. This should work. Yep. Loops while for. So we can see here 0, 1, 2, 3, 4, so on. And we scroll down and we get all the way down to 50, which is perfect. That's exactly what we wanted. Now what would happen if I went to 50? It's not going to give us this flag. I'm going to copy and paste this flag just so that way I don't lose it. But if I were to go ahead and you notice we restarted our streak. TryHackMe was down yesterday, so I had to restart my streak. But if we go ahead and get rid of this 51 and make it a 50, run the code now, you see we're not going to get that. We only get up to 49. So important to know that. Okay. Introduction to functions. As programs start to get bigger and more complex, some of your code will be repetitive, writing the same code to do the same calculations, and this is where functions come in. A function is a block of code that can be called at different places in your program. You could have a function to work out a calculation such as the distance between 2 points on a map, or output formatted text based on certain conditions. Having functions removes repetitive code, as the function's purpose can be used multiple times throughout a program. So let's look at a basic function here. Definition, or def, define, say hello, name. So this is the argument. This is the actual function here. So print hello plus name plus nice to meet you. Say hello, Ben, so name right there. Those are the same. So say hello, Ben. Output is hello, Ben, nice to meet you. So anytime we change that name, it's going to be whatever we put in there. There are some key components we can note from this function. The def keyword indicates the beginning of a function. The function is followed by a name that the programmer defines and is a function parameter. In our example, it's say hello, right here. Following the function name is a pair of parentheses that holds input values, data that we can pass into the function. In our example, it's a name. Again, that's right here, and that's what I was talking about whenever I said these are back and forth, right? In your mind, if you think about it that way. And then a colon marks the end of the function header. Okay, and that's right there. In the function, notice the indentation. Similar to if statements, anything after the colon is indented is considered part of the function. A function can also return a result. See the code block below. So, let's see. Def calc cost item. If item is sweets, if item is equal to sweets, then return $3.99. Else if item is equal to oranges, return $1.99. Else return 99. Okay. Spent is 10. Spent is 10 plus calc cost sweets. Print you have spent plus str, so string spent. So we have to define that that's a string, because if we don't, I think it's going to throw an error. If we call the calc cost function and pass in sweets as the item parameter, the function will return a decimal number in the code above. We take a variable called spent and add the cost of sweets through the calc cost function, then we call calc cost. It will return the number of $3.99. So let's just see what happens when we actually copy paste that. Okay, you have spent $13.99. Why do we get $13.99? Because we have sweets. Spent is spent plus calc cost sweets. So the item is sweets. So we return $3.99. We spent $10 already, so we take spent and then add the calc cost of sweets. You have spent the spent string right here. So you have spent $13.99 because we have 10 plus $3.99. Makes sense. Answer the questions below. You've invested in Bitcoin and want to write a program that tells you when the value of Bitcoin falls below a particular value in dollars. In the code editor, click on the bitcoin.py tab. Write a function called Bitcoin to USD. Do that. Bitcoin to USD with two parameters: Bitcoin amount, the amount of Bitcoin you own, and Bitcoin value USD, the value of Bitcoin in USD. The function should return USD value, which is your Bitcoin value in USD. To calculate this in the function, you times Bitcoin amount variable by Bitcoin value USD variable and return the value. The start of the function should look like this. Okay, Once you've written the Bitcoin to USD function, use it to calculate the value of your Bitcoin in USD, and then create an if statement to determine if the value falls below 30,000. If it does, I'll put a message to alert you via a print statement. Okay. All right. So let's go ahead and start defining, I guess right here. All right. So def Bitcoin to USD. Now, if you notice, I'm not copy pasting this right here. And the reason why I'm not is because I'm trying to teach myself this. And whenever you're doing any kind of code, if you can, you should just write it out instead of copy pasting for the most part, because it helps your brain lock in those synapses. Bitcoin amount, Bitcoin value USD. Okay, so that's the beginning. All right, and then it wants us to return USD value, which is your Bitcoin value.
A few moments later.
Replace the okay, so this is what we really want. Bitcoin to USD. Right, so Bitcoin amount, and then we want Bitcoin value USD. USD value is Bitcoin amount times Bitcoin value USD. So far this is exactly the way we had it. Investment in USD is this is different. Investment in USD is Bitcoin to USD. Investment in Bitcoin, Bitcoin to USD. Right. If investment in USD is less than or equal to 30,000, rent investment below 30,000, sell investment above 30,000, right? Run code. Okay, so that gave us what we wanted. Why though? Well, let's see, where did I screw up? Investment in USD is, I didn't have that, investment in USD. Bitcoin to USD is Bitcoin and USD. So, right, we're calling the function, and then investment in Bitcoin, right? So that's right, that's what we had. And then Bitcoin to USD, right? So that's pretty much what we had. So we did not have the less than or equal to. That might have been what we were missing, less than or equal to. Okay, it's pretty similar. Okay, one Bitcoin is now 24,000 if the code editor on line 14 updates in the code editor. Okay, so we update this to line 14, but that would have been if it was the original. So we'll say it's 24,000, and then run the code. Investment below 30,000, sell. So that's pretty cool. All right, so that's functions. We'll definitely come back to that some more. That's a tricky one, functions are. In Python, you can read and write from files. We've seen that in cybersecurity. It's common to write a script and import or export it from a file, whether that be as a way to store the output of your script or to import a list of 100s list of hundreds of websites from a file to enumerate. Let's dive straight into an example. F is open, file name, R, and then print f.read. To open the file, we use the built-in open function, and the R parameter stands for read and is used as we're reading the contents of the file. The variable has a read method for reading the contents of the file. You can also use the read lines method and loop over each line in the file, useful if you have a list where each item is on a new line. In the example above, the file is in the same folder as the Python script. If it were elsewhere, you would need to specify the full path of the file. You can also create and write files. If you're writing to an existing file, you open the file first and use the A in the open function after the file name call, which stands for append. If you're writing to a new file, you use the W instead of A. See the example below for clarity. F is open, demo file.text A, append to an existing file. F.write, the file will include more text. F.close. F is open, demo file, text W, creating and writing to a new file. F.write, demo file 2, file created with this content in. F.close, notice that we use the close method after writing to a file. This closes the file, so no more writing to the file within the program can occur. The code editor write Python code to read the flag.txt file. Okay, so let's see. So we'll say F is open to read the flag.txt file. And we'll say flag.txt. And then we'll say R for read. And then we'll see where that gets us. Run code. Nope, not getting us anywhere quite yet. Okay. F.write. Well, I guess we just want to do F.close. Oh no, I'm so sorry. Print F.read. Right? Yeah. THM file read. All right. So that's how we read files. So if F is open, flag.txt, read, R for read, and then print F.read. And lastly, imports. In Python, we can import libraries, which are a collection of files that contain functions. Think of importing a library as importing functions you can use that have been already written for you. For example, there is a date library that gives you access to hundreds of different functions for anything date and time related. Import date time. Current time is datetime.datetime.now. Print current time. Okay. We import other libraries using the import keyword. Then in Python, we use that imports library name to reference its functions. In the example above, we import datetime, then access the now method by calling library name method name. Copy and paste the example above into the code editor. Okay. So yeah, this is important. So methods are important, and that's what these little datetime now. Okay. Run that code. Okay. So 2023 828. All right. 102852. All right. We import other libraries using the import keyword. Then in Python, we use that import library name to reference its function. Oh yeah, we already went through that. Okay. Here are some popular libraries you may find useful in scripting as a pen tester. Request, simple HTTP library, Scapy, send, sniff, dissect, and forge network packets, and pwn tools, a CTF and exploit development library. Many of these libraries are already built into the programming language. However, libraries written by other programmers not already installed on your machine can be installed using an application called pip, which is Python's package manager. Let's say you want to install the Scapy library, which allows you to craft your own packets in code and send them to other machines. You install it first by running the command pip install Scapy, after which in your program you can now import the Scapy library. Read the task and run the Python example code above in the code editor on the right, which we've already done. So we'll hit completed, and that completes this room. So thanks for riding along with me. This is it for the Python stuff, and we'll go ahead and continue on, do something a little different, and then come back to Python eventually. So thanks for riding along. I appreciate it. And again, I'm Sean Woleslagle, cybersecurity, and I appreciate your time. Thanks.